Good afternoon. Thank you for being here. My name is Danilo, and I joined Amazon Web Services almost 7 years ago now. It's been a long ride. I started as a solution architect, then I moved into this evangelist role. And since last year, I'm 100% focused on serverless technologies. And that's because at the end of 2014, when we launched AWS Lambda, I really was impressed by the speed of the development that you could achieve with serverless technologies. And actually, I was so impressed that I also wrote a book that has been translated to Chinese and Korean. And I work with my publisher to have a free ebook. So the last one on your right is a free ebook that gives you an understanding of the most important technologies to create an agile serverless development environment. And the idea of this talk, to move serverless into the next level, came to me because I think creating a serverless function, like a Lambda function on AWS, is not that complex. It's not really something that I should advocate anymore. And when I start to meet customers, they tell me, okay, I know how to create a function, maybe to connect this function with a bucket so that if I upload a document or an image, I can automatically process it. But how can you use serverless to do something bigger, something more important? So talking with our customers, I started to collect those that are the most important ideas that they share with me. And that's what I would like to do today. So the first point is infrastructure as code. I don't know if any of you participated to the awesome talk by last minute this morning. So infrastructure as code, I think, is the stepping stone to start to do development in a different way. And by infrastructure as code, I mean that you have some text file that describes the infrastructure that you want to build. And since a cloud environment is completely programmable, there are tools that can build what is described in this text file. And this makes changes to your infrastructure repeatable because you can just edit file to repeat the changes. It makes easy to release infrastructure change in the same way you release an update to your application code. And it makes creating replicas of your production environment easy, so that if you want to create an integration test environment, you can just create a new implementation of your template describing the infrastructure. And actually, there's lots of tools to do infrastructure as code, but the most important characteristic that you should look is not to choose a tool that is imperative, that has an imperative syntax, where you try to tell to the platform what the platform needs to do, but a declarative syntax, where you tell the platform what you need, and the platform is capable of understanding, for example, if there are dependencies, ordering how to build these things. Now, most of the times when we develop applications, we use imperative programming languages, but actually we also use declarative ones. For example, if you run a SQL select is a declarative syntax because you tell the database what you want to get, and then the database will choose based on its own optimizer how to run the select on the physical data on the disk. So it's quite a broad concept, and declarative syntax works much better for infrastructure as code. And then you can put the description of your infrastructure together in the same repository as your application code. You can do deployments that include infrastructure change. And there are lots of tools. So on AWS, you can use CloudFormation. It's a service that we released lots of years ago now. Or HashiCorp, they have a nice open source solution that's called Terraform. And what about serverless? So with serverless, we don't have physical infrastructure to configure, but still we have lots of components that we want to set up and tailor to our needs. So you have serverless functions like Lambda functions, you have database tables, buckets where you store object data. And probably the two most common choices that I see is the serverless framework, that is an open source project. And as AWS, we created a serverless application model that we released as open source so that everybody in the industry can reuse the same model if they want. And it's designed to be a simplification of CloudFormation for serverless environment. So this is an example of a template that creates a function that works as an API. So in these 20 lines of code, I'm saying, okay, this is a serverless function. This serverless function is using these permissions. In this case, the permission give read access to a database table. The event triggering this function should be an API call with this path, and you can pass parameters from the URL. In this case, the resource ID is a parameter that is passed to the function. And you can create a database table using DynamoDB in this case. By the way, last year we launched DynamoDB on demand, so now you don't need to set up a throughput to a DynamoDB table. It really scales automatically, and if you use it for development purposes, or even at low scale, you almost don't have no cost by DynamoDB now. And to make easier the development of serverless application, we launched also this other open source tool that is called the SAM Commandline Interface. You can install it with pip. You can then initialize an application using the programming language among one of the officially supported ones, like Python in this case. And then inside the directory, you find all the scaffolding with the description that you need. We set up unit tests for all the common platforms so that you know how to start and do also unit testing. And then you can use some local to generate synthetic events. So with serverless function, when you want to test if the serverless function, they work, a very good practice is to create synthetic events that you inject to the function, and then you can test them and see if they behave in the way you expect them. And this is one of the features of the tool. You can also run functions locally, or emulate the API gateway, or emulate the Lambda invoke API locally. We use Docker containers in this case that emulate the execution environment that we use on the Lambda platform. And then there are these 4 commands that are probably the most important ones. You can validate the template to be sure that the syntax is correct. If you use YAML, it's very easy to make something not compliant, or if you add just a space. And then you can do the build, and then upload the package to an S3 bucket and do the deployment. And you can repeat these 4 commands as often as you want, because every time you do a deployment, CloudFormation will compare what is already there and do the adjustment both on the infrastructure and on the code of your application. So this is something that you can put into your CI/CD pipeline to do continuous deployment. You can use any tool. So we have a plugin for Jenkins, for example, for the Sun CLI, or you can use tools like AWS Code Pipeline that we created starting from an internal tool that we have in Amazon that is called with lots of originality pipelines. And with SAM, you can also tail the logs of your function when they are deployed in the cloud. And if you want, you can also publish the whole serverless application privately within your account so that other people in your AWS account can use it, or publicly so that other people can reuse this application whenever they want. And the idea with serverless application is that now they can also be nested. So we launched this idea last year at reinvent, our yearly conference in Vegas. And the idea is that we see that lots of customers have recurring requirements, but they require some customization. So for example, lots of customers, they want to monitor social media. So this is just an example of how you can use nested application. And if you want to build a serverless application to monitor, for example, Twitter, it's very easy. You can set up a polling schedule using CloudWatch events that maybe every 5 minutes trigger a Lambda function that is using the Twitter search API to see if, for example, your brand or your products are mentioned on Twitter. You can store the checkpoint that is returned by the Twitter search API, and the checkpoint is something that you can reuse for the next search, so that you only search for newer tweets. And then you can have a custom Twitter processor that is doing something custom. So some customer, they just want to, for example, store the tweets mentioning them for further analytics. Other customers, they run sentiment analysis on the tweets, and if they are negative, they are passed automatically to the customer support that then can act on those tweets. So here we have a standard component that solves a very generic problem, and something custom, the Twitter processor, that every customer wants to do slightly different. So now in a serverless application using SAM, you can write something like this. I want to embed in my application another application. This is the ID. This is a semantic version of the application I want to use. And then in the parameters of this application that is embedded, I can pass, for example, the text to search, or the Twitter processor function name that is another function that I'm declaring in the same template for the same stack. So this is an example of how you can reuse a composed serverless application one inside the other, and I think there's lots of interesting use cases that you can use. But in Amazon, we like to experiment with new things. There was already today someone that mentioned the fact that serverless, the infrastructure as code is actually infrastructure as YAML, because YAML is not really code. So we now have this project that is in developer preview now, It's called the Cloud Development Kit, and here you can use your own favorite language to describe the infrastructure you want to build. So this is not serverless specific. With this, you can create anything on AWS, and you can use TypeScript, C or F#, Java, Python, and we're looking to add other languages to this framework. And you can create an application that is described here, and then use CDK synth to synthesize the CloudFormation template to implement this architecture. You can automatically deploy or run a difference, so compare what's in your file with what is already deployed to see the difference, and of course destroy, for example, if it's a test environment. And this tool is also designed to be included into your favorite CI/CD pipeline. So this is an example. I'm using TypeScript here. Definitely for the CDK to be useful, it's interesting to use a strongly typed language, because in this case, the IDE can drive you doing the change and write the right code. So this is written in TypeScript and is extending a CloudFormation stack to create a Lambda cron function, so a function that is executed periodically. And this block here is declaring the Lambda function with a specific name. There is a code file that is read, and the normal option of a Lambda function, the handler, the timeout, the runtime. This other block of text is defining a CloudWatch event rule, and then I connect the rule with the target, that is the Lambda function, so that I think every day, Monday to Friday at 6 p.m., this function is triggered and does possibly something useful. So you can use different languages, but this is the idea. So when you have infrastructure as code, the next step is really to start to automate your deployments. And by automation, I need to do both continuous integration. That means that when you commit your code to your source repo, you automatically get a build or a broken build if something goes wrong. But also continuous deployment. So the idea that maybe going through some automated test phase, you can automatically deploy in production. And to do so, you really need to do small deployments. You can't do a large deployment automatically in production. It would be too risky. It's very important to do small and frequent deployments during the day. And for serverless, as we saw, we have a template describing an infrastructure, your application code, and we go through 2 stages. We package the application, we deploy the application, and we create an implementation of that we call a stack. And then probably in production, you want to have a test stack where you run some automated tests, and then you deploy into the production stack. And here you can start to get the feedback. And what I've seen from lots of customers is that the speed at which you can deploy and give something in the hands of your customer and get a feedback from them, using, for example, some monitoring of what they do with the application, this speed is really the speed of your deployment. You can be as fast as you want as a developer, but if you don't get a feedback from your customer, you don't know if you're going in the right direction or not. And to make deployment safer, we also added a feature to the Lambda platform to support natively canary and linear deployments. So the idea is, for example, here I have an API that is built with the API gateway. I have a Lambda function, and it's at version 1. This works also not for APIs, but this is just an example. And then I want to release version 2 of my function. So what you can do, you can create a version 2 of your function, but still no user has access to this version. Then you can run optionally what we call a pre-traffic hook. This is another Lambda function that does whatever you want to test the function before it's released to other users. So for example, you can do smoke test and see if everything works. This is the production environment, so you can also run synthetic transaction and see that everything works. And then if it works, it goes into the canary phase, where you can have slow deployments that start to move invocation slowly from the previous version to the new version. And then when all the users are on the new version, you can optionally run another hook function. We call it a post-traffic hook that, again, does whatever you want. For example, can annotate your Git repo, say that that Git commit is actually being deployed in production. Because with CI/CD, you assume that every commit goes in production, but that's not true, because it can be pulled back if there is an error. So this annotation gives you the real ID that it's in production for any test or patch that you need to manage afterwards. And to do all those things, you just need to add a few lines of code to the same template. So you don't need to configure anything else on AWS. We do that for you. So in the same template, you need to add auto-publish alias that says that every time you publish a new version, this goes under a specific alias, in this case, live or prod or something like that. Then you can choose your deployment preference, and we have a list of standard deployment that you can use, like canary or linear deployments. A canary deployment is a two-stage deployment, like 10% of the users, 10% of the invocations goes to the new version for some time, and then it's open to everybody. With linear deployment, you can slowly add 10% every 1 minute, every 3 minutes, or every 10 minutes, or so on. And during this canary phase or linear phase, you can set up alarms. On AWS, those are CloudWatch alarms that can monitor that everything works. For example, you can monitor if you get any error from your function or if the latency of your API is increasing too much. If there is an error, we roll back automatically to the previous version. And then you can define the pre and post traffic hook as I described before. So all those lines, and you get a standard behavior. And you can define this at function level or at global level, and it will apply to all the functions in the stack. We also have the possibility of creating canary stage in the API gateway. This is slightly different. There's no automation in this case, but it's also very fine-grained. So the idea here is that you can release a version 2 of an API, create a canary stage, and move, for example, 0.1% of your users to this new version. And I think this is also designed to be more long-lived than a traditional deployment. So for example, if you change something in your application, you can have this running for 1 hour or 1 day, and then compare if the users are really working better with the new version or not from that analytics that you can collect. After you automate deployments, the next step, in my opinion, is to move from the idea of running projects to product management. And this is something we do a lot in Amazon. We normally don't talk about product managers, but we have project managers, we have product managers in AWS. And the idea is that a project really moves you to think into releases. Like there's version 1, now I have to focus all my resources to reach version 2, and then version 3 is targeting the end of the year. With product management, you try to follow what your customer needs, and this is not a straight line anymore, and the customer needs always change. For example, when we release a new feature one evening on AWS, the day after I get called from customer telling me, hey, now that we have this feature, we also want this because otherwise we can't do that. So it's very easy to get this kind of feedback, and it's awesome. And also, projects really tend to focus your energy towards the next milestone, where product focus you to look for creating value for your customers. So when you build a project, you usually think in terms of how much time and resources do I need for the next release. With product, you are more forced to think into the cost of the life cycle of the product. If you build a car, it's not how much does it cost to build a car, it's how much does it cost to maintain a car on the street with replaceable parts for maybe the next 10 years. And this should be the same attitude we should have with software. How much does it cost to keep it running, adjust it if things change, and they will definitely change in the next few years. So projects are backward-looking methodologies. What product really bring you value and bring you to look into the future. Project works very well if you have something static. If you need to build a bridge, if you need to build something that is not changing continuously. Product works very well for something dynamic. And normally with product development, there are 4 main reasons why you want to do a change in your product. You want to add features, you want to solve some bugs or defects, you want to reduce some risk, like a security risk, or you want to reduce internal debts that you accumulate, like technical debts. And you get different feedback from different teams inside your company that tells you which one you need to do. But what is often missing, and it's something that we try very hard in Amazon, is to get the feedback from your customer, not just for bugs, but also for new features. And this should go and be filtered by your business so that they can help prioritize the right new features to be built in the next few weeks and months. And since this is now a dynamic environment, you can't plan for 1 year like in a normal project. You should avoid overutilization of your teams. You probably should look for having your resources busy at 70, 80%, no more, because you need to leave some space for adjusting and changing as new things happen and you get new feedback. And for example, one reason to do that, and It's something that we wrote in our letter to our shareholders in 2015. So as a publicly listed company, we write every year a letter to the people investing in Amazon. And that year we wrote something that I really like. We wrote that we are really a very good place, very brave and very good in failure. So it's something that we're very good at. We have plenty of practice, and you can find lots of examples of things that we tried in Amazon and failed miserably, like you may remember the Amazon phone from a few years ago. But failure and inventions are inseparable twins, so you can't innovate if you don't try something and it fails. So as a product development team, you should think that failure is part of what you do. So when you move to product development, the next step is to build the product to be composed of small parts. And these small parts should interact in an event-driven way. Events is something that we talk a lot when we talk about serverless functions like Lambda, but I think it's really important. So more recently, I'm hearing lots of discussion about maybe monoliths are not so bad. Actually, the problem that I see is that sometimes people is over-engineering microservices, creating too small components, or thinking that you can build microservices right from scratch. I think it needs some experience to do that. But in this case, we're really fighting the laws of our universe. So complexity is now a science, and in the last probably 20, 30 years has been studied across different fields such as mathematics, physics, biology, social science. And what we saw, and this book is really interesting in that perspective, is that things become complex when there are dependencies among the items that compose this thing. And a large code base is very difficult. You really need to be a very good developer to avoid dependencies across different components of your application. That's why we use functional programming. That's why we use object-oriented programming. But if you use microservices, you really have clear boundaries, and you can easily reduce and mitigate the risk of creating dependencies. And those dependencies is what affect your application when you do a release and you have side effects that then we call bugs. And one specific part that is really important with microservices is how you integrate these microservices together. And there are three very common approach here that you should evaluate. One is a message queue. A message queue means if you have a producer and a consumer of some kind of information, and probably this producer and consumer don't go always at the same speed, you should use a message queue in the middle. You should always avoid synchronous integration, because if you create synchronous integration, that's most probably a distributed monolith, not a microservice architecture. If you can share the same information with multiple consumers, with multiple subscribers, then a pub-sub architecture is really interesting. And sometimes my suggestion is, if you create some information, so if some of your microservices create information, for example, a fraud detection system can publish if there is a fraud inside your architecture by someone pretending to be one of your customers. Don't keep this information somewhere close, but publish it as a topic so that every other service that may be interested in this information can subscribe and act on that information. So information sharing as topics is really a good practice for microservices architecture. And lastly, if you have some distributed data point that is evolved by, for example, multiple transactions. Let's think of, for example, of an ordering system where you order something on the web, a random example being from Amazon. You order something on the web, and then it takes a few hours or a few days to get this item delivered. This is a distributed state that starts as an open order. Then we have to check the fraud, the payment, the availability of the product. We start the shipment. We update with the shipment progress until it's delivered or not delivered. So this is the kind of workflow that is very common in business architecture. I think inside Amazon, we developed at least 10 different workflow systems to solve this kind of problem. A few of those reached the public, so I'm encouraging you, don't redevelop again the same technologies. We have something available for you in AWS that can really help and manage this kind of distributed state. And also with microservices, and also with serverless specifically, I often hear people talking about latency, for example, with cold starts. And the idea is that we should really understand latency. So there is this book from Brendan Gregg that really gives a nice description of what you should expect in terms of latency when you do something in an IT architecture. If we stay inside the CPU, we are in the nanoseconds range. If we start, for example, to use the internet, we are in the milliseconds range, and so on. And if we look at the speed of the CPU compared to a traditional reboot of a server, if a CPU cycle is 1 second, the reboot of a server is 32 millennia. So it's really a lot of difference between the scale of this approach. And when you look at latency, you should also measure them in the correct way. So inside AWS or inside Amazon, you can't say the latency of this service is this. You should say, this is the percentiles of my latency that I'm experiencing. And percentiles is a way to describe data in a more statistical way. So percentiles or P number means that, for example, the P50 means that this is the value where 50% of the observation of the latency are below this value. P90 means that 90% of the observation are below this value, and P100 is, of course, the maximum value they are observed. This is a real graph from actually one of the AWS API, and here we have something like P50, so the median statistically is 0.4 seconds, and then we have P90 is 1 second, P99 is 5 seconds, and P100, so the maximum value, is 24 seconds. So there's quite a huge variance in the latency here. Can you think of which AWS API is this? This is from the EC2 control plane, and it's the autoscaling API. And the reason you see this variance is because autoscaling is managing autoscaling group that are of servers that are automatically scaled. And while most of the customers have 1 or 2 digits in numbers of servers, we have some customers that have tens or thousands of servers in a single autoscaling group, and that's causing the high variance that you see here. But this is really a way to understand how you work, how things happen, and then you can understand if you need to mitigate or not this latency. And with microservices, it's also important to understand what happens when a single transaction is crossing the boundary of multiple microservices. So correlation IDs and tracing of a single transaction across different requests is really important. We also implemented that as a service, if you want, but you can also build that with correlation ID in logs. And this is, for example, how to design the map of an architecture of your application, and then you can drill down and understand each invocation from one function, for example, to DynamoDB or to other services, what is happening, and if there is too much latency or if there are errors, and at which level. And also, as I said at the beginning, it's very important to leverage the fact that this serverless function is triggered by events. And you can really build event-driven architecture that, in my perspective, are much easier to manage. So I created this tool that is actually an open source tool. And by the way, it runs completely in the browser. There's no need of an AWS account here. And for example, you can start with a basic API. And this is an API where you have the API gateway, a Lambda function, and a DynamoDB table. And here you can give an application name, and then you can download the SAM or serverless framework template to start playing with this technology. You can also choose the deployment preference, as I described before. But is this an event-driven architecture? I think it's very basic. So if you want to think event-driven, for example, we can add here also an S3 bucket. So a bucket is where you can store objects. So this is my bucket. Let's call it like this. And then I can connect the bucket with the Lambda function. So now I'm storing structured data into the database and unstructured data in the bucket. And now I can start to be event-driven because I can add here another Lambda function. And this is my bucket processor. So my bucket processor is something that every time something is written in the bucket is triggered and is processing on what is changing there. And again, I can add my table processor here. So let's create a Lambda function. This is my table processor. And then I can connect this with the DynamoDB table. So now this starts to be a sort of an event sourcing architecture where something arrives, is filtered depending on the kind of content, and then I store it, persisted, and then I can act on the logic. So for example, I get a customer request, it's stored here, and then depending on the request, I trigger one or another Lambda function to process this request. So this starts to be event-driven. So always try to think in this way. And this is something more theoretic for now, but I really like the idea. So this is a book from Nassim Taleb. So he's an economist, and he was thinking about the idea of antifragility. So in terms of economy, the problem with globalization is that if one country in the world has an issue with an economy, then the whole world is affected. But similarly, we can think in something similar in our architecture. Can we make our architecture not just resilient, but really that are used to receiving and managing faults? Let's make an example with our immune system. If our immune system is continuously managing microinfections, solving them, and then if we get something more stronger, then we can process this infection in an easy way. If I live under a glass bell for a few years, my immune system doesn't receive microinfection, but if I remove the bell, then probably the first infection I get would be too strong to be managed. Can we write application that can really be used to managing these small attacks, small faults, and that can really improve automatically by that? If you think of chaos engineering and all the tools that companies like Gremlin and Netflix released, probably we're already going in that direction. But this is, for me now, just a nice idea. When I build something, I try to think, can I build this as an anti-fragile component? So after microservices, the next step that I think is really important is focusing on your team. In Amazon, we have this approach. This is our CTO that says, you build it, you run it. So each team is responsible for what they build, and normally they give the second level of support on what they build. This really puts the development team in contact with customers, and this is super important. You have direct contact, and not just matrix or analytics that tells you what your customers are doing. And when we build those teams cross-functional, so that you have different expertise. So let's start with the team size. How big can be a team? So let's say that I want to build a team for an interesting project. I need to, as I said before, to build a team that can do also support. So I can take a huge team and then I can solve the problem. The problem with team size is communication. So if I have 3 people in my team, there are 3 communication paths inside my team. How many communication paths do I get if I have 5 people? Anybody wants to try? With 5 people, you get 10 communication paths. And if I have 10 people, with 10 people, you get 45 communication paths, because it grows with the square of the number of the people in your team. So it's simply not human. Apart from Facebook, we can have more than probably 10 friends. And the idea here is, if I create too big a team, it will automatically decompose into smaller teams that create out of nowhere and probably are not managed. So the idea is create small teams. We call them the 2 pizza teams, so that they are fed by 2 American pizza that are bigger than the Italian pizza, of course. So the idea is 5 people. Probably 5 people is a good size for a team. 3 if it's a simple project. Never more than 7 people, because more than 7 people, it's too complex for a team to work together in the right way. So that's how we create teams and we create team size. But what about the cross-functional side? So why we look for cross-functional skills inside the team? And the reason is because there are normally 2 kinds of tasks that we solve. One kind of task is what we can call a separable task. So if I want to, for example, replace all these screens here on the desk, I can do that myself, or maybe 5, 6 people comes here and we do that in parallel. It's an easy separable task. But when we create an application, this is a complex task. It's something that everybody works together and gives a different perspective. There will be people more capable of seeing something happening in the front end, in the back end, on the data, on the algorithm side. So to understand why we need cross-functional team, let's try to build a simple model. No? People say that all models are wrong, but some are useful. So hopefully this is a useful one. So let's say that we can map the ability of people as a list, and let's use letters. No? So A, B, C, D, E are the 5 abilities that Adam has in his own portfolio of cognitive tools. And A can be, for example, mobile development on iOS or backend development in Java, data analytics in Python, SQL, and so on. You can think of more relevant tools for your own use case. And let's say that I have these 3 people where each one has different skills identified by the letter. And then I want to build the best team out of 2 people, because it's a 3 people. I want to build the best team out of these 3 people. So normally one can say, okay, let's take the best people, and I have the best team. So I take the best people with 4 and 5 abilities, but there's lots of overlap. They know almost the same things. So they have 6 unique, distinctive cognitive tools in their portfolio. If I take the 2 worst people in this team, I get more abilities. So probably this team is capable of finding other solutions that the other team would not think of. So it can possibly find a better solution to the problem you're trying to solve. And this is what it's normally called a diversity bonus model. It really shows you in a simple way why we need diversity and we need cross-functional skills in our teams. So normally, diversity can mean not just knowledge, it means also identity diversity. So maybe having been studied in different universities gives you different approach in solving the same problem, and so on. And if there's no diversity, there's no bonus. So, and this is normally a big problem when the hiring manager is a single person and he hires people that are similar to him, because everybody will be probably a subset of the hiring manager, and you can create any team you want, nobody will be better than the team leader. And another niche problem is that sometimes some cognitive tools must be learned in order. Let's say that I want to create a team that is focused on image recognition with machine learning and convolutional neural networks. Probably each of these people needs to know neural networks, convolutional neural networks, linear algebra. So this is not random skills. You need to learn them in a specific order. So here it's even more difficult. So definitely having people coming from different universities can help. And also, thinking a little bit out of the box can help. So maybe even if it's a neural network project, I take someone that has a more statistical approach for machine learning. It can provide a different perspective and find different solutions for the problem. And then when I create this small 2-pizza team with cross-functional skill, should I keep this team working always, all of the time, or should I change the team sometimes? So here there's an interesting study. At the end, the problem we want to solve when it's a complex problem is a problem of creativity. And one very large creative data set that we have is what happened in Broadway in New York City. And there's actually some people that studied what happened with 2,000 people working in musicals in Broadway for 40 years, more than 40 years. And they look at the team that worked in these 474 musicals. And they wrote an article, and they defined one parameter that is called Q, that defines how often people work together. So a team with a very low Q means that they never worked together before. It's the first time they do a musical. Team with a very high Q means that they worked together a lot in the past. And then they looked how Q was affecting reviews and revenues of the musical. So who here thinks that a very low Q, so people never worked together before, gave a very high score for reviews and revenues? 2 people. 3? Exactly. Who thinks that a very high Q, so people they work together a lot, gave a very high result in terms of reviews and revenues? Probably the same number. Who thinks that an average value of Q gives the best result? I kept it last as a trick, of course. And the half value is what gives. So, of course, a very low Q gives the worst result. But after some point, I think it can be interpreted as we fall into habit. We try to solve the problems always in the same way because we worked together in the past for lots of years. So the idea is create small cross-functional teams and keep a core and change the people around this core so that nobody stays in the same team for too much time. How much time? That depends on what you do. Definitely, someone must be part of a team until you reach some specific goal that gives retribution to the people working in the team, but not too much. So after focus on your team, the other important part as a developer, and this is probably not just for serverless, is don't reinvent the wheel. I think it's one of the sentences that I heard the most today. And we work, for example, with our customer to share their stories so that you can understand what works and what doesn't work with using serverless architecture. This is Capital One. It's a bank in the US and in the UK. They were speaking with me at reinvent in Vegas last year. We did a session together. And they are using a serverless architecture for what they call a credit offer API. This is an API that they use to advertise their credit cards with those comparison websites where you can compare your credit card with another credit card, and also to start the registration of new users from that website so that they didn't need to type the registration data again and again every time. So you can imagine the level of privacy and compliance that they have on this kind of information. And they build it serverless with Lambda functions. They use nice tricks like on DynamoDB, they use time to live to automatically expire old records in the database so that the database always keep only the latest records that they need. And the old data is automatically received as an event by another Lambda function that is storing the old records on an S3 bucket for analytics. So all data is automatically expired to S3 for analytics. They use X-ray for monitoring, as I was showing before. And they use also the deployment tools that I was talking before. So before they moved to Lambda, they were deploying once per week at, I think, at 2 a.m. on Monday. Someone from the team was to be there, and it was a weekly deployment. When they moved to serverless, they now do 2 deployments per day in production using canary deployments with alarms monitoring the deployment. And this is also a multi-region architecture. So they have the deployment on the west and east coast of the US on 2 different regions with data replication in the middle. And in this way, they have a very high availability and low latency for their US customers. And they told us that they saw huge performance gains. The reason of the performance gains is that when they moved into serverless, they basically took the previous Java application and they moved it into a Lambda function, wrapped into a Lambda function. But then they wanted to experience with other technologies. And one of the advantages of microservices is that you can rebuild each component in a usable amount of time using a different technology. So they wanted to have experience with Go. So they rewrote the functions in Go. And they did the deployment. They switched from Java to Go for some of the components, and they see that Go actually runs very well inside Lambda, so that's why they see these huge performance gains. The cost saving is huge. They moved from EC2, ELB, RDS, replicated across multiple regions to Lambda function and DynamoDB. And what I find really interesting is that they told us that since now they deploy often, they don't need to go during the night. It's like they have 30% more time in their team. And that's why a small team working on serverless can be more efficient than a large team working on more traditional architectures. More recently, I love this use case. So this is a technical article that has been published, I think, 1 week ago. And what they did, they used Lambda function to execute an optimization, to solve an optimization problem. This is a logistic regression. If you're into machine learning, logistic regression is the most common way to optimize a machine learning algorithm and find the parameter for a machine learning algorithm and do the training. And they found a way to run this in parallel with Lambda function at very high scale. So the Lambda function is the green one, and it takes almost half of the time that other parallel approach that they tried before. And if you are into mathematical optimization, they use a variation of the Newton model to find the minimum of a continuous function, of a convex continuous function in this case. I also try to share a bit in my GitHub account. So if you're looking for ideas, I have a few projects there. This is what I call a positive chat that I built. And it's a chat where if you write something negative, it's rejected. And it tells you, please find a better way to rephrase what you're writing. I think it can be useful because as humans, we're not very good with written communication, I would say, and social networks in general. It also automatically translates, so you can choose the language you want to receive your messages, and everything will be translated because this helps cross-functional teams crossing borders work together better. So if you want to play 1 second with this, oh, sorry, I think I have this QR code. So if you want to join, I have a chat room for Vox Days. It's optional. Going back to the fun of the initial keynote, maybe not everybody wants to participate. So I'm going now on the chat. As usual, I lost the cursor. Make it a little bit bigger. So you should have something like this. There's no authentication, so you can choose your own user and the language. And this is currently what I left yesterday or the day before. If I write, for example, I hate this demo, file has been translated to bin. As you can see, when I wrote, please find something negative, it was rejected. And then I can choose to get everything in Italian if I want. Or I want to use something more exotic, at least for me, like Japanese. And you can still write in any language. It's just the translation that works in that direction. So why I was showing this demo? Because the whole application, front-end and back-end, it's 460 lines of code. And it runs serverless, so it's automatically replicated, code and data, across 3 data centers, and you don't have to do anything. It scales automatically from 1 chat per second to thousands of requests if you want. So this is an example of how you can build something interesting. So don't reinvent the wheel, and learn and be curious. I think that's the best approach as a developer. If you look at some of the ideas that I use today, and those are mainly the books I used, only a couple of these are actually related to IT or software development. Most of them come from completely different fields, such as the diversity bonus or economics, or even projects to product is more of a methodology book. But look for other ideas because it's the best way to learn. And I think as a developer, we have a great responsibility ahead of us. Thank you. We have 5 minutes for questions, yeah? Questions can be, of course, also in Italian.
Parlando di antifragilità e di architettura eventi, la disponibilità di un sistema fatto così è l'interazione della disponibilità, quindi si riduce. Quali sono le misure per mitigare cascade failures e altro?
So the question is how to do anti-fragility with an event-driven architecture where we have lots of components interacting, and each fault can possibly be a fault for the whole system. So apart from having high availability built in each component, you should design an interaction that works and has fallbacks. So for example, I'm currently working with Comic Relief, that is a no-profit organization in the UK. They are speaking with me in the summit that we have there at the beginning of May in London. And they moved their payment platform, so the way they receive donation for the Red Nose Day is the day where they receive 95% of the donation each year. You can compare it to Telethon in Italy, to give you an idea. It's covered by the BBC. They started 3 years ago with serverless. This year, they moved this donation platform to serverless, and they built lots of resilience. So for example, each component was failing. They had SQSQ to move everything asynchronously and store and manage that letters queue in case of errors. So the idea for platforms like Telethon or the Red Nose Day is that they want to have the donation updated in real time, because on the TV screen, it's good that you see the donation updated. But if something breaks, they were going asynchronously. And they had multiple fallbacks across one region and another region, so that they can go multi-region. So if even an entire AWS region would be down, they could switch everything to the other region. If each component was falling down, there was an asynchronous queue to collect the information and redirect the information for further processing. So it can be tricky, of course, but at the end, the availability of a distributed architecture can be better than a centralized monolith, where if something goes wrong, it can be really hard to debug. I think we have time for another question, if you want. Okay.
So you mentioned Go as one of the implementations from Lambda. Do you have any thoughts on implementing functions using Go versus Java?
Yeah, so the question is on the runtime, so Go versus Java. So I think that Go is definitely a very fast language by design. The difference with serverless function compared to traditional application is that they can somehow be short-living. So the JVM historical has been optimized for long-living process as an application server, so it can be very slow to start. In our experience is also the creation of objects at the beginning of a Java application that can slow down the initial setup. So just to clarify, when you use a Lambda function, the first time that after a few hours, we create a sandbox environment that is running inside a micro VM. And then if you receive more requests, we create multiple sandbox environments in parallel. This initial request can be slower. It's what is normally referred as a cold start. And it depends on the JVM or the runtime platform start, plus the initial startup of your application. With Java, you have a slower startup time with the JVM, and even worse, if you use some standard Java libraries, they can be very slow at the beginning because they load everything into memory, thinking that they're running long-term into a container or a platform. So you need to be careful in what you use. With Go, this is more of a natural approach. So I would say if you don't want to enter into optimization problem, Go is very easy to use. If you use Java, we have lots of customers, but you have to be careful about which libraries you use. Okay, I think, let's, very quick.
Per mitigare questo problema un po', pensare a utilizzare GraalVM per la
So how can we mitigate the JVM? So the JVM is not the big culprit here. Often is the code, initialization code. But we now release the possibility to have custom runtimes, so you can bring your own runtimes, and there's lots of different Java virtual machine that you can use, and you can find that. And we're also looking into what to do with JVMs in general. As you know, as Amazon, we contributed with Corretto, the open JVM supporting for quite a few years JVM 8, and we're going to look into what we have now JVM 12 in bed, I think. Thank you again.